सब्सक्राइब करें हमारे यूट्यूब चैनल mathemetical लेक्चर को और बेल आइकन को दबा के लेटेस्ट वीडियो सबसे पहले
whether x is positive or negative, this theorem is applicable. For example, we want to find the value of 1.006 whole to the power 1 by 3. This power may be positive, negative, whole number or fraction, any number it may be. Now if we convert this expression in this form, 1 plus 0.006 whole to the power 1 by 3, and since this number is much less than 1, it is less than 5 or 6%, therefore we can write it this way, and it will be 1 plus 0.002, or it comes out to be 1.002. And if we actually find this cube root, then it comes out to be very close to this. So this is approximate value of 1.006 whole to the power 1 by 3. Another example, suppose we have to find this 1 upon root of 4.002. Now first of all, it is greater than 4. If we convert this expression as 4.002 whole to the power minus 1 by 2. Actually square root means 1 by 2 power, and when it is taken to the numerator side, it becomes minus 1 by 2. Now I write it to be like this. I have broken it into two parts, and here we are having 4 and not 1, so we cannot apply binomial theorem on this. First we have to take this 4 out of the bracket, and it will be 4 to the power minus half, and will be plus 0.0005 whole to the power minus 1 by 2. And this expression can be simplified. We can take it to the denominator side, 4 to the power 1 by 2, that will be root 4 or 1 by 2. And here we can apply binomial theorem. This power is multiplied to this. It is 1 by 2, 1 minus 0.00025, and it will be 5, 7, 9, 9, 9, 0 upon 2, and divided by 2, you'll get the approximate value of 1 by root of 4.002. It is 4, 9, 9, 8, 7, 5. So this is the approximate value, which is very very close to the actual one of 1 upon root 4.002. So students, today we have discussed the topics of trigonometry and two topics of algebra, binomial theorem and quadratic equation. In the next class we will be studying remaining topics of the 180 minus theta, etc. And for this there are certain rules. First of all, we'll learn how to write an unknown angle in quadrant. For example, if we write a simple angle theta, then it is considered to be in first quadrant. However, this value of theta is not known to us, but we always assume it to be a small angle for finding the values of 90 plus and minus theta, etc. Like this. Cos and not only 90, it may be 180, etc., as I have told you. Now the unknown angle, which for these expressions we always assume it to be small, then the angle in first quadrant will be either written as theta or it can be written as 90 minus something. When we subtract something from 90, then the angle is again in first quadrant. So the angle in first quadrant will be written as theta or 90 minus theta. On the same pattern, if we go beyond 90, then we get the angle 90 plus something, that is 90 plus theta. And similarly, if we move up to 180 and then come back, then this angle will be 180 minus theta. So the angle in second quadrant can also be written as 180 minus theta. And on the same basis, the angle in third quadrant will be 180 plus theta or 270 minus theta. 270 is up to this minus something. We reach the third quadrant. And similarly for the fourth quadrant, the angle will be either 270 plus theta or 360 minus theta. And on the same pattern, if we further move, the angle in first quadrant will be 360 plus theta. So these are the angles in different quadrants, unknown angles. Now, the value of sine 90 minus theta is simple, and you have learned it into previous class. It is easily well known that the value of sine 90 minus theta is cos theta, and the value of sine 90 plus theta. Now we learned this type of expression. You have already learned this cos 90 minus theta, it will be sine theta, and similarly if we are having tan 90 minus theta, it is cot theta. But when we change this minus into plus, that means 90 plus theta, or we use 180 in place of 90 or 270 etc., then the rules change. It is not simply that sine converts into cos, cos converts into sine. No, it is not simply that. For example, in this case, sine 90 plus theta, it comes out to be cos, but in this case, cos 90 plus theta, it comes out to be minus sine. So here we see that there is a difference of this negative sign. Similar are other cases of 180 etc. Suppose I write tan 180 minus theta, it comes out to be minus tan theta. And how these values come about, I am going to tell you, I am going to teach you about these values, when to put minus and when to change. Cos is changed into sine. For example, I have tan 270 minus theta. Here it converts into cot. But here the answer is positive. Now there are two types of changes. Either the answer is positive or negative. And there may be another change. Either the sine is converted into cos, cos into sine, tan into cot, etc. Or sine remains same or tan remains same, just like this, tan here, and the answer is also in tan. Sometimes we have to change sine into cos, cos into sine, etc. And sometimes we have to put a minus in the result. So how these values are written, we are going to learn these rules. All the trigonometric ratios in first quadrant are positive, and sine in second quadrant is positive, tan in third quadrant is positive, cos in fourth